Hello, good morning, good evening, namaste, namaskara to everyone out there. I hope you are all doing safe and are in good health. I'm excited to be part of TPS 2020. Today, I'm here to talk to you about the work we've been doing on SQL containers at Microsoft. Most of our customers have already started their digital transformation journey, and one of the steps in that digital transformation is data estate modernization. And with SQL containers, we actually provide you that one step that you can take towards data modernization. Now, in this session, what I really want you to take back from this session is a mindset which basically says, wow, this SQL containers is really easy to get started with. I think we should start using this right away. That is the mindset that I would want to see that you can take back from this session. With that said, I think it's time for us to jump into the session right in. And a quick introduction before we jump into the session about myself. My name is Amit Khandelwal. I'm a senior program manager with Microsoft. I've been working with SQL Server for more than a decade now. And before this, I was also working at Microsoft PFE, working with customers, building their solution, architecturing them, and doing some cool stuff with SQL Server. So with that said, I think it's time for us to now jump in to the agenda. So in the agenda slide, what I want to really talk about is the topics that we are going to cover today. So the way we are going to start our session is first we are going to talk about why should you even be using SQL Server. After which, we are going to talk about the different deployment options that you have for your SQL Server containers. Post which, we are going to talk about the SQL Server container scenarios, where or what scenarios can you use SQL Server containers in, and what business problems can you really solve SQL Server using SQL Server containers. Now, please remember that the scenarios I'm talking here about are the scenarios that I have seen customers use it, but I would always love to see any new scenarios that you might have in your environment after going through the session that you've started using SQL Server containers for. And with that said, a presentation or or an information about SQL Server containers cannot be without demos. I have really some super cool demos that I want to show you, which basically is going to convince you enough that you can start using SQL Server containers for your production environments as well. And then I'm going to talk about the most critical aspect that we always talk about when we run something in production environment. Let me give you some chance to take a guess. I'm sure you guessed it all. I am going to talk about the performance parameter, how you can tune performance when you're working with SQL Server containers. What are some of those knobs that you can turn and twist to ensure that SQL Server gives you best of the performance? Post which, I'm going to talk about one quick thing as well, which is about how are you going to deploy SQL Server containers on container orchestration environments. So when I say container orchestration environments, what I basically mean is environments like Kubernetes or OpenShift. If you want to deploy SQL Server on those environments, how can you go about doing that? I have a demo for that as well. So get ready. This is going to be a journey of lots and lots of demos and less of slides. Anyways, with that said, I've just kept last 15 minutes of our 75 minutes. The last 15 minutes is specifically as Q&A. I'm sure you'll have a lot of questions, and I hope that I'm able to answer those. And if I'm not, what I can promise is I can get you the answers for those questions. All right. With that, I think it's time for us to now get started with the session. So first, let's talk about why should you even use SQL Server containers? Honestly, I've been speaking about SQL Server containers now for about 6-7 months, and I've in various conferences. This is the first question that I always get post the conference: that why should I even go with SQL Server containers? And that's why in my latest sessions, what I've started doing is I've started adding a slide which basically explains why should you even start using SQL Server containers. So to get started with it, let's see why should you use it. The first thing that actually comes when talks about containers is portability, and it's no different for SQL Server itself. So when I say portable, what I really mean is that SQL Server dependencies and SQL Server itself is packaged into one single package, which you can take and deploy on environment of your choice. So you can take this package and you can download this package from any of these package container, container catalogs like the Docker Hub or Red Hat catalog that you have. You can just download this package and run it on the on let's say a machine which is running on premises, or let's say you want to run it in cloud, or now you can also run SQL Server containers on the edge devices. So that's the portability that we talk about. The next thing that I really want to focus upon is no installation that is required for SQL Server containers. This is a key advantage of using SQL Server containers. You don't install, but you deploy SQL containers. In case of SQL Server containers, all the binaries are actually laid out already, and you just when you just deploy it, you just start using it. So think of it as something like a zip file, which you unzip and you start running your exe programs. That's exactly what I mean by no installation. So within seconds you can get started with it. The next point that I want to talk about is the security. Now, SQL Server containers, they run on a host, and the container is actually a service which is running on that particular host. Now, when I say SQL Server is secure, SQL Server containers is secure, what I basically mean is starting SQL 2019, we made it a default option that when you deploy a SQL Server container, you deploy it in a non-root user mode, which basically means that when you log in into that container, you basically log in with the non-root privileges. And ensuring that you log in with non-root privileges, what it ensures is that you don't expose any vulnerability which can be utilized in the containers to actually cause harm to your host. So that's a key feature that I want to talk about. Second features are the security features that you get with SQL Server Engine across Linux or Windows. Those security features are also available for SQL containers. So things like TDE, they work for SQL container, SSL works for SQL Server containers, and you can actually configure SQL Server containers on host which are which runs those security enhanced Linux submodules like SE Linux or App Armor. So on those hosts as well, SQL Server containers can be run. So I'm going to show you a lot of demos where we are going to talk about how you can enable SSL, how you can enable Active Directory authentication for SQL Server. We are going to talk about that as well. The next thing I really want to talk about is the ease of use. Now it's portable, you don't need installation, and by default it's secure. So isn't it easy to use? I mean, you can just by a click of button within seconds, you can have a SQL Server installation running in your environment, which otherwise would have taken you at least, if you're installing SQL Server on Windows, it would have taken you at least about 10 minutes. If you're doing it on Linux, it would have probably taken you a few minutes. But with containers, you can get it up and running within seconds. That's the ease of use that I'm talking about. The next aspect is SQL Server containers is completely configurable and customizable. We do not go with an approach of one size fit all with SQL Server containers. You might be thinking that, okay, it's by default secure, no installation required, it is portable, easy to use. That means I really cannot modify this according to my needs. That is not correct. You can modify SQL Server containers as per your need, as per your requirement. Let's say you don't want to use the SQL Server containers that we ship in MCR, SQL Server containers which are built upon the base OS images of Red Hat or base OS images of Ubuntu. You don't want to use that, but you want to build your own SQL Server container on, let's say, a SUSE image or a SLES image that you want to work with. You can do that. You can create a Docker file, and I'm going to show you a demo of how you can do that as well, so that if you want to customize and configure your SQL Server, you can do that at any given point of time. Next, what I want to talk about, When I say containers, most of the people think that containers is a stateless application and SQL Server is a stateful application. So will my database state be saved once I deploy a container, stop it and rerun that container? Will the data be saved? And what I want to tell you is yes, you have a mode in which you can deploy SQL Server container in a stateless mode. But at the same time, you also have a mode where you can deploy SQL Server in a stateful mode, which means all the data changes that you do, all the tables that you create, all the data that you feed in can be saved. And the time you stop SQL Server and restart it, it is there following all the asset properties that you would expect it to follow when running SQL Server anywhere. So with that said, I hope I've answered your question about why you should be using SQL Server containers. Now let's go ahead and see what are the deployment options that you really have with SQL Server containers. Now, this is a slide which I really don't want to talk a lot about, but want you to actually look at it and just see the number of options that you have. And that's why I'm just going to take a pause for like 2 seconds for you just to go look at the slide and see the number of options that you have and how you can deploy container in your environment. So if in your environment you are discussing your leadership teams, you are discussing about having SQL Server enabled in microservices kind of an architecture where you have a lot of applications running in Kubernetes or running on containers, and you want to deploy SQL Server, you want to take SQL Server also into that architecture, here are your options. You can deploy it on Kubernetes, you can deploy it on OpenShift. Now, the Kubernetes could be an on-premises version of a Kubernetes deployment, or it could be a cloud infra deployment. If it's a cloud infra deployment, it could be a managed service like an AKS or Azure Red Hat OpenShift, where OpenShift is the opinionated version of the Kubernetes cluster. At the same point of time, you want to deploy your own custom Kubernetes cluster on cloud, public cloud environment, you could do that, and SQL Server will be supported on that as well. Similarly, you'd want a standalone container deployment for SQL Server, you could do that on a bare Linux host or a bare metal machine. You could actually just do that. So the idea that I want for you to take away from this specific slide is that you can deploy SQL Server containers pretty much, in a lot of environments, and those environments are listed here. And we have a documentation out there which also speaks about the exact versions which are supported for them. Great. With that said, it's time for me to just give you a little, journey around the history of SQL Server containers. I know I'm not going to give you a big information about it. I'm going to keep it very short, but I really wanted to bring this so that I can share with you the amount of work that we've been doing on SQL containers in the last 2 years. So the SQL Server containers really started in year 2017, and that was the time when we started supporting SQL Server on Linux. And that's exactly the time where we started having SQL Server containers. But at that time, SQL Server containers was only available on Ubuntu OS. And by default, it did not run as a non-root. But come SQL 2019, we did a lot of changes. We brought in a lot of features. Some of them where we started supporting running SQL Server on multiple operating systems, like you see. We now support SQL Server containers on all the operating systems on which we support SQL Server on Linux. We also ensured that by default SQL Server container starts in a non-root mode, and we also built our own products and solutions on top of SQL Server containers. So SQL Server Big Data Cluster is nothing but a product built with foundations from SQL Server containers, SQL Server Linux containers to be very specific. And another question that I keep getting in my session is about that when we speak about SQL Server containers, we only speak a lot about SQL Server and Linux containers. What about Windows containers? Now, to answer that specific question, SQL Server and Windows containers is also available, but that's right now in a preview mode. But SQL Server and Linux containers is completely GA supported for production environments. And we are working for the Windows version as well. But right now, that's the state. And that's why most of my sessions are focused on the production ready features and the production ready SQL Server Linux container and not on the preview mode of SQL Server Windows container. Now, with that said, today we just don't have SQL Server BDC, but we have products like Azure SQL Edge, which also runs on SQL Server containers. We have Arc data services, which are now previewed. Probably you've heard about them in the Ignite. If you've not, there's a session that is going to be about Arc, which you should be attending to know about this, because this is going to be the real hybrid solution that you would want to look at when deploying SQL Server containers or when deploying SQL Server, as a product. And what I want to also add quickly here is SQL Server Containers is here to stay. It's not going anywhere tomorrow, day after tomorrow, or in the future. And this is a commitment that we kind of have to build the product. And this is the commitment that I just wanted to showcase here as well. So far, with this history behind, let's go ahead and look and answer one of the most important questions that I always get. Okay, Amit, we've heard enough from you about why should I use SQL Server containers, the history of SQL Server containers, the deployment options of SQL Server containers. But tell me, what specific scenarios are customers using SQL Server containers today? And as we speak, these are the scenarios that I have seen customers use SQL Server containers. These are not I'm talking about these scenarios not to limit your imagination, but actually to tell you what other customers are doing right now. But you can definitely see any other business solution that you want to solve using SQL containers, you could pretty much use there as well. So some of the scenarios that I have seen where customers are using it is, the first thing I want to cover is about multiple instances of SQL Server on Linux. Now, if you've been from an environment where you're running SQL Server on Windows, one thing that you might have seen is on Windows host, you can run multiple instances of SQL Server. We have named instances of SQL Server, and then we have the default instance of SQL Server, and you can have multiple named instances of SQL Server running on the same host on a Windows environment. With SQL Server on Linux, we did not have this option. So SQL Server on Linux can only run one instance of SQL Server on a host. And we had a lot of customers asking us that if we want to utilize the resources of the host in much optimized way, we would love to see if we can run multiple instances of SQL Server on Linux. And the option that you have available today is SQL Server containers. With SQL Server containers, you can deploy multiple containers of SQL Server on the single host with different names. So when you deploy SQL Server containers, I'm going to show you a demo of that as well. When you deploy SQL Server containers, you basically provide a variable called -h, which is host name, where you actually give a name to your container as well as the host name. So -n is the name of the container and -h is the name of the host name of the container. And we normally recommend that you have both of these parameters defined when you do a deploy, when you do a Docker run or a podman run command that you run. And host name basically is the name that you would want to see when you run select add server name against that SQL Server instance. The name that you would want to see there is the name that you would pass in the -h. So SQL Server containers makes it possible that you can deploy multiple SQL Server containers, which is nothing but multiple SQL Server instances on the same host, which enables you to utilize optimally the resources that are available on the host. So that's one location where we've seen a lot of customers use it, where they can run OLTP environment and they can run their reporting environments all on that one single host. The second place where I've actually seen a lot of customers use is when they want to create their own database as a service module a model in which they want to have a database as service. Today, when you want to create that, the biggest problem that you would have is on one single instance, when you create multiple databases and each of those databases belong to a specific team or a specific project, the problem that you have is accounting for the resources. Accounting for the resources in terms of how much CPU, how much memory, how much disk space is being utilized by each of those databases. That accounting is easy on an instance level when compared to on a database level. And with so much of data regulations coming up, you would not want multiple different projects or a different team members working on the same single instance on different databases, because you would still have something shared. What you can do is, in such scenarios, you can deploy multiple SQL Server containers. So when the project starts, a SQL Server container is deployed for that particular team, for those users, and people can access that database. And once the project finishes, you can just delete that that instance or that container, SQL Server container, with the project lifetime, so that you can manage your instance lifetime with the project lifetime and account for resources in a much easier fashion. That's the other place that I've seen customers use SQL Server containers in production environments. The other place which I've seen is the usage of SQL Server containers is very high in dev and in UAT environments. Think of this. You have an application where you made a change to an application, and now you want to see or test that change against multiple versions of SQL Server. So if you do it in the old way, you would probably have to sit down, install SQL Server in on multiple hosts, and then run your application against all those multiple instances or multiple hosts that are running. But with SQL Server containers, all of this deployment of container and running this application change can be made easier, because you are deploying it in seconds and getting your UAT and dev environment up and running with the SQL Server data, and you can get started and run the changes that you've done to the application. So ad hoc tests against multiple versions of SQL Server, uh, that is totally made easier with SQL Server containers. The other place that I've seen a lot of usage for SQL Server containers is when you have the CI/CD pipelines and you want your database to be part of that CI/CD pipeline. So basically, when someone clicks on build, it should create a database, and as soon as the pipeline is done doing its job, it should just delete that database or delete that instance of SQL Server. That exactly is made possible using SQL Server containers, because you can just integrate it with your CI/CD DevOps pipelines and start working as though database was also part of it. And as you click on build, the database gets created, and once you're done, it just gets deleted. So these are some of the scenarios that I've seen customers use it. But as I said, please do not limit yourself to only these deployments. These are just an examples for you to get started with, but the sky is just the limit for your imagination of where you can start using SQL Server containers. With that said, I think we've covered good amount of details about why should you use SQL containers, what are the scenarios you can use SQL Server containers for, and now it's really time for us to look at some of the cool features and demos that we have. But before we get into demos, I would just request another 5 minutes of slides here. And I promise this is just going to be the last few slides that I want to show, and then we are going to get into the demos to get started with our session. Great. The next thing that I want to talk about is some of those features that we've built in. And the first thing that I want to really talk about here is the option of non-root SQL Server containers and how that is made possible and how it runs by default. And I'm going to show you a demo of this covering about non-root SQL Server containers. The second thing I want to talk about to you is, again, how you can set up SQL Server containers on a host which is running SE Linux. And when you run SE Linux or App Armor, there are certain labelings that you need to change when you're mounting the volumes. And what are those changes that you need to do? That's something that I'm going to cover here. The third aspect that I'm going to cover, as well as show you a demo about, is how you can enable SSL encryption for SQL Server containers. Now, for the demo, I'm just going to show you SSL encryption, but you can also enable TDE at the database level for a SQL Server container as well. So what I really want you to understand is all the features that work with SQL Server on Linux is completely supported with SQL Server on containers as well. So whatever features you can run, like in-memory, OLTP, replication, DTC transactions, or you just name it, whatever feature you run with SQL Server on Linux, that exactly runs in a supported way for SQL Server containers as well. So there is 100% feature parity over there. The next thing I want to talk to you about is how you can do a customized, how you can create your own SQL Server container. How can you customize your SQL Server container? I have a Docker file for that, which I want to share with you. Of course, all the demo that I'm going to do is going to be shared with you, but I'm going to show you how you can create your own Docker container or a container image using slash base OS image. That's another option that I'm going to do. The only thing I want to talk about here for a minute is when you're customizing SQL Server containers, please remember customized SQL Server containers are supported when they're built on the supported versions of SQL Server on Linux. So SQL Server on Linux, like today, is supported on RHEL, Ubuntu, SLES. So if you build your SQL Server container on any of these operating systems, that is completely supported. And one last point that I want to add here is the base OS image that is used in SQL Server container must match the host OS image that you're using. So for example, if you're using Ubuntu as a host to run SQL Server containers, you should build your SQL Server containers on Ubuntu base OS image. Similarly, if you're running RHEL, you should build it on RHEL base OS image. So the OS image and the base OS image of the container should actually match. With that, the most weighted feature for SQL Server Container and the feature that I'm really excited about is the support for Active Directory authentication. We've made, we made the process of enabling AD authentication for SQL Server containers really, really seamless by bringing in a new tool called AD Util. And I am going to show you a demo of how you can use this tool to actually go ahead and enable AD authentication for SQL Server. As we speak, this tool is still in preview, and you'll see an update in our documentations very soon about how you can get started with it. So probably by the time you see this session, you should see about this tool called AD Util and how you can use this tool to actually start working with Active Directory authentication. And the last but not the least demo that I really want to show you is when you're running multiple SQL Server containers on the same host, you would want to limit the resources for each container. And how would you do that? That's another demo that I would want to show you. Now, with all these demos lined up, I think it's time for us to get started with the demo. But what if I said just one last slide before we get into the demo? Because I want to talk to you about AD Util here to tell you how you can get started with it and what this AD Util tool is all about. So AD Util tool, as I said, is a tool that helps you manage and interact with your Active Directory from a Linux machine. So it's actually a CLI based utility created to actually make your experience completely seamless when you're configuring Active Directory authentication for SQL Server Linux or for containers, for that matter of fact. Now, using AD Util, not only can you manage just the Windows domain, but you can also manage the Samba domain using AD Util as well. And the last point, you can, using AD Util, you can create key tabs, you can create users, you can manage users, you can go ahead and create SPNs, you can manage SPNs, you can show SPNs. So basically you can interact with an Active Directory sitting from your Linux server without actually going to a Windows OS server to create user and then come back to Linux and then go back and create SPNs and then come back to Linux, create the key tabs. You really do not want to do any of those things at this point of time. So with that said, that completes the session. I'm just kidding. Now it's time for us to go and look at the demos that you've been waiting for. So let's get started, and let me open up the screen here. So this, let me just increase the font here for a second so that it's all visible. All right, with this, let's go ahead and start our demo. So I am right now on a Linux machine which is running RHEL 8, and I have already downloaded the AD Util tool, and the download instructions for the AD Util will be available. When I'm doing the demo today, this is the latest version of AD Util, but probably when you will start working with it, the version would have changed. That should be okay. That should not be a problem. And what I want to talk to you about is first introduce you to the environment. Now, this is an machine which is already part of the domain. As you can see, when I do a realm list, you can see the domain name being mentioned here. So it's already part of the domain. I am going to run my container on this machine, which is called as rel no domain. So the name is probably gives you a hint that this is not joined to any domain. So right there, you can see I did a realm list. It's not joined to any domain. So what I'm going to do is I'm going to run a container on this machine, the rel no domain machine. And when I'm running the container is going to be joined to a domain. So the container will support AD authentication, but the host is not part of the domain. All right, now let's see how can I get started with it. The first thing that I told you about AD-util is you can use this utility to go ahead and create users, create SPN. So let me tell you what we are going to do in this domain. The first thing that I'm going to show you in this demo is using AD-util. I'm going to create a user in my Active Directory. Then I am going to create an SPNs under that user. And then to link all of this together, I'm going to create a key tab file, which is going to have the SPN and the user details created again on this machine, post which I'm going to copy the the file that I created, which is the key tab file that I created from this machine, the rel2 machine, to the rel no domain machine, so that I can load my key tab file to the container. In the same demo, what I'm also going to show you is how you can go ahead and encrypt the connections coming to the SQL server. So I'm going to show you both of these, demos together. Also, what I'm going to do is to enable SSL encryption, I'm going to create a self-signed certificate. Now, for this demo, I'm creating a self-signed certificate, but for production environments, that's not recommended. What is recommended is you get a third-party certificate to use for encryption, like you would do it for Windows. Great. So with all that said, let's go ahead and start working with it. The first command that I want to show you, hopefully you can see my screen, is realm list, and you can see I'm part of the contoso.com domain. And let me just increase the font size to ensure that you all can see it. Great. So now what I'm going to do is, as I said, the instructions or the commands to install AD-util will be shared. So right now, this is the version that I'm using. The first thing that I'm going to do is I'm going to create a user called as SQL Pass user. And what I'm going to do here is you can see I've given the name for the user. This is the user that I'm going to create in my Active Directory. Then I'm going to go ahead and also provide the distinct name, which basically is the name of the user, the organizational unit where I want to create, the domain name, and all of those details. And then I pass the password for this user. Again, for the purpose of demo, I'm passing this password in plain text, but what is recommended is you don't pass it in plain text, but probably you can pass it interactively, to the AD-util. So you can do it interactively, or you could also pass it through a configuration file, anything that works best for you. Now, I'm not going to run this command because I've already done that to save time. So once you run this, this is going to go ahead and create a user in Active Directory domain, which you can find in your AD. And then what I'm going to do is I'm going to go ahead and create the SPNs. Now, before you run AD-util tool, one most important thing that you need to check is you need to kn it into your machine. Right now, I have already done that. So you can see, I can see the different tickets that I currently have in my cache. So I have created the user now. The next step that I'm going to do is create an SPN. And to create the SPN, all I've got to do is run this command add util SPN, add auto, as you can see. Now, when I say add auto, I need to provide the host name, which should be the fully qualified domain name of the SQL Server container. Now, I am going to give the container that I'm going to create on my rel no domain machine is this with this name. The SQL pass is going to be the name of that container. So I'm going to go ahead and create this one over here. And SQL pass is the name of my container, not the name of the host. Okay. And 5433 is the port number that is going to be mapped on the host with the SQL Server container. So this is what I'm going to do. Again, I'm not going to run this command because I've already done this. To see the SPNs already created, I can just run a command like this, where I can say the name of the user is SQL pass user. There's a typo there. As you can see, the SPNs are already created. These are the SPNs that I've already created. These are the SPNs for the container that is mapped with this particular user. So I've created the SPNs, I've created the user. The next thing I've got to do now is create the key tab. Now to create the key tab, the command that I'm going to use is this. So this is a key tab that I'm going to create in the location here, which I'm already part of, which is my working directory right now. And the username to whom I want to map this is the SQL pass user. And then I provide the password. Now, when I hit enter, I'm just going to hit enter, but not create this. It'll ask me the encryption types that I want to use. You can choose more than one encryption if you'd like. But you need to choose those encryption types that are supported in your environment. For example, I know AES 256 and ARC4 HMAC, both of them are supported. So if I have to choose more than one encryption types, I just give the values and then hit enter. This is going to create the key tab. I'm not going to do that because I've already created it before we started the demo. So I have once I create the key tab, what I need to do is also create the key tab for the SPNs that was created. So the command for doing that is here. As you can see, I say adutil key tab create auto, the same location or the same key tab file, because when you add anything in the key tab, it's an append that happens, not an update. And then provide the fully qualified domain name of your container and ensure the passwords that you pass are the same for the user, because this is the same user password that you need to pass. Again, please don't pass the passwords in the plain text like I've done. This is just a demo, that's why I'm doing it. For production, please do follow the recommended practices of using interactive password method or using the configuration file. So once I do all of this, it's going to go ahead and create the MS SQL key tab. And then for SSL encryption, I'm also going to go ahead and show you the command that I used to create my MS SQL key and MS SQL.pem files. Now, these are the files that are nothing but your certificate and the private key associated with that certificate. And because SQL Server supports RSA keys, that's why I've used an RSA key. The most important part of this is, again, when I'm creating the subject name for my certificate, it should match with the fully qualified domain name or the name that you're going to use in your SQL, in your client connections to that SQL container. So sqlpass.contoso.com is the fully qualified domain name of my container that I'm going to use in my client connections when connecting to it. So once I do all of this, you would see it is going to go ahead and create the MS SQL key, MS SQL key tab, and MS SQL PEM, which is the certificate, the private key associated with this certificate, and the key tab for my AD authentication. Please remember, key tab is required for the AD authentication. The mssql.key and mssql.pem are the certificate and the private key for that certificate, which is required to encrypt my connection to SQL Server. Great. So what I do, I have created all these files on a machine which is already connected to the domain. Now you can go ahead and then copy the MS SQL key tab file, which is created from a machine which is on the domain. It's not necessary for you for encrypting SSL and for encrypting connections to SQL Server. It's really not necessary to create MS SQL PEM and MS SQL key files on the host which is connected to domain. You could definitely go ahead and run OpenSSL command here and create the files here. I just did it for the sake because I was just on this machine, so I just created here. So I copy all these three files onto my other machine, Again, let me just increase the font here to ensure you can all see the font in the recording. So now what I do is I just do a realm list again, just to show you this is not connected to any domain. I have copied my files, the MS SQL key tab file, the key file, and the PEM file over here, which were all created from the machine, which is part of the domain. Now to run my uh, uh, container, the command I'm going to use is podman run. Now let me do this. Let me just clear this file and run the command here, just so that I can take you through what each of this command is doing. So I'm just going to show you here. So please look at the screen here to understand what I'm actually doing. Right now, what I'm doing is I'm saying podman run, which is deploy a container for me with these environment variables. Again, please do not pass SA password the way I've done it. If you do, after you create the container, the first step that you need to do is connect to your SQL Server container using SA password and change the SA password using tsql alter SA password options. Then what I'm going to do is map my port to the port which is running SQL Server container. So on the container, SQL Server is listing on 1433, but I'm mapping that to 5433 port on the host. Then I give the container name. This is the name of the container. Then there is -h parameter where I provide the name of the server or the host name. So if you connect to that container and run select at that server name, this is the name that's going to be returned to you. Now, the next set of commands that you see here highlighted, which I'm doing, is a volume mount of the container, and I'm mounting the MS SQL to the SQL pass folder on my container. And then I'm also mounting the curb config file. I'm also mounting the MS SQL PEM file to this location on the container. And then I'm mounting the key file as well to this location, so that when the SQL Server container starts, it's able to identify these files and set up the environment accordingly. Now, because I'm running all of this in Azure, I need to add these options as well to ensure that I bypass the DNS of Azure and connect to the DNS servers mentioned here. 10.0.0.4 is the DNS or the domain controller in my environment. So now when I run this command, this is going to start a container now, which is called a SQL pass, as you can see, because that's the name I've given to the container. Now, before I go into the detail, I really want to show you what I have in my MS SQL config file so that I can enable SSL and I can enable Active Directory authentication. So the first thing that I have in my, let me just clear this again. So I have more space here, and let's just go through the MS SQL config file. As you can see, I have these four settings that I've highlighted. This is required to enable the SSL setting. And these two lines that I've highlighted here is required for enabling the Active Directory authentication. So please remember, I'm doing both Active Directory authentication and SSL encryption in the same demo. That's why this is the config file that looks like. Now, if you remember in my podman run command, I also had the curb5.config file, which basically was mounted to the container. The reason I mounted that to the container was so that my container, my curb5.config file has the information of the domain controller. So if I just show you the config file, it's basically the information of domain controller and where my KDC lives, the name of my host. So with this information, what I've basically done is I've set up my container to ensure that it's going ahead and able to pick, it's able to pick these files and load and mount them here. Now, another important aspect that I wanted to show you in this is with every mount, I have specifically used this option :Z or :Z as they call. Now, why have I used this option? As I said, SQL Server containers do support hosts running SE Linux. Now, if I have to check the SE status on my box here, you will see it's currently enabled as, and it is in the enforcing mode right now. So SE Linux is enabled. Because SE Linux is enabled, I need to ensure that the labels for this volume is such that it lets my container write into these locations. And that is why I'm using :Z. If I don't use :Z, then this container is going to not start and it's going to fail on machines which have SE enabled. So you need to ensure that the labels match, or the labels allow you to go ahead and write into the host container files. So with this, let me just see the status. My container is currently up and running. So let's go ahead and load the certificate into this box so that I can go ahead and encrypt my connection. This is my client right now. So what I've done is I have imported my mssql.pem file in the trusted root certificate authority. And to load the certificate, all I did was I first copied the mssql pem file into this folder, and then I can just go ahead and import this particular certificate as you can see on the screen. Once I do next and I click finish, it's going to load the certificate, and I've already done that over here beforehand. So the certificate is all up and loaded. What I've also done is I first will go ahead and connect with the SA authentication, right? And look here, I have enabled the connection as encrypted. And when I hit connect, it goes ahead and connects to it. And then I can go ahead and create a login, which is a Active Directory login. This is a domain login, which is there. This is a Windows login. I'm just going to go ahead and create this. Once I create this, I can quickly check under the logins, the account is created, and then go back here, change to Windows authentication, again, encrypt the connection and connect to it. Remember, sqlpass.contoso.com is the name of my container, and bingo, there you go. You have an Active Directory authentication working for SQL Server container on a host which is not connected to the domain, but the SQL Server container is. And please remember, the name of your container should match the certificate so that your encryption, the SSL encryption works for your SQL Server. So with this demo, I want to show you how easy, with 5 steps with ADUtil, I created a user, I created a SPN, created the key tabs, copied over the files to the other box, created an MS SQL config file to tell what was my privileged AD user and to tell where my key tab files are, and then mounted those files on top of the container and just started the container. And here you go, I have Active Directory authentication enabled. So as you can see, with less than 5 minutes, I was able to go ahead and create and enable Active Directory authentication working for SQL Server containers with SSL encryptions also enabled. And all of this on a host which has SE Linux also enabled. So you are completely in a secure environment. Now, before after this, the other quick demo that I want to really show here is about the non-root containers that you have. So as you can see, I have a container which is running right now over here. Sorry, it wasn't on the wrong machine. So as you can see, I have a container which is running right now, which is SQL Pass. So let's say, let me go ahead and connect to this SQL Pass container. So when I want to connect to the SQL Pass container, I'll go podman exec -it SQL Pass, and then I open a bash command. And then if I type a simple command as who am I, you can see I'm inside that container. Inside that container, I opened a bash command. And when I typed who am I, you can see it's an MS SQL user, which is the non-root SQL Server user, which gets created when you create containers. So I am currently logged in as a non-root user, non-root container. And this is exactly what I was talking about when I said the containers run in non-root user. And that's what you see over here. Great. Now, you've seen this. Now, another information that I really want to share here is you can always, because I'm on RHEL 8 machine, I'm actually using Podman, but you can all do this with Docker as well. So I can simply go ahead and create a simple alias here, which is saying Docker equal to Podman, and then just do Docker PS minus A and it works. So at the backend, it's Podman again working for you, but RHEL 8 right now supports Podman on this and not Docker. So what I want to show you with this is that even if you go ahead, your SQL Server containers, you can work whatever demos I'm showing you here, they work exactly the same even for the Docker scenarios as well. So you don't really have to limit yourself with just Podman. I mean, you can use any OCI compliant tool and start working with SQL Server containers. So now what I want to show you is how you can limit resources for each of the containers. The first thing that I'm going to show you right now is when you start a container without limiting any resources, it takes complete resources that are available on the host. And then I'm going to also show you a way of how you can limit resources and start a container. So what we're going to do is, hopefully you can see the screen. The first thing I'm going to do is podman run command, where I'm actually not going to give any limits to the resources. And what this is basically going to do is going to use all the resources that are available on the host right away. So when I run this command, you will see the SQL Server is going to deploy a container. And when I just go ahead and look at the logs, which I can do using this command, which is podman logs, the name of the container, give a space, and then let's say I just want to read the first 35 lines. Now, as you can see, I have about 16 GB of memory on my machine, and right now SQL Server is using about 12.6 GB. I think it's not 12.6, it's probably 12 GB. Out of 16 GB, it's using all 12 GB. Now, the reason it's just using 80% of the overall memory is because by default, when you start SQL Server, it's not going to use all the memory that's available on the host. It's only going to use 80% of the host memory. And you can change that behavior using MSSQL config option. But what I really want to tell you is right now it's using 80% of the entire memory that I have on my host. Now, let me show you a way where you can limit this resource, not only in terms of memory, but also in terms of CPU. So to do that, I'm going to show you a command, which is sudo podman run. And here you can actually see I'm creating a new container called as SQL memory cap. And I'm going to limit my memory to 3G. So when I run the same logs command, what I expect to see is that we are only using 80% of 3 GB, which is about 2.4 GB. So let's see if this is true. So now this container is deployed. Now let's just look at the logs for this container as well. So which is podman logs, the name of the container, and then let's say I just again want to see the first 35 lines of the logs. Now, as you can see, bingo, there we go. We have specifically limited our resources and we've given only 2.5 GB or 3 GB of memory to this. Now, if you want SQL Server to use all the 3 GB, all you have to do is create an MSSQL config file like I showed you in the AD util demo, and then start, give SQL Server to use the entire memory that's available. So with this, you can now see I can limit CPU, I can limit memory, I can limit basically the resources that are there for each of the containers. Now, what I want to show you is another demo where how you can create your own configure your own container from the scratch. I don't want to download anything from using the pull commands, but rather want to create my own container using a Docker file. So now what I'm going to do is I'm going to switch to my slash machine, which is a SUSE machine. And what I've done here is I've already created a Docker file, and what the Docker file basically contains is I am downloading a OS image, the first thing. Then I'm going ahead and downloading another package that I need. In this case, as an example, I have used the libcap program, but you could also download any package that you would need apart from the SQL Server. And then I have gone ahead, installed SQL Server and SQL Server tools with the options to accept EULA and interact with non-interactively run the setup. And then I'm going to go ahead and give right amount of permissions on the SQL Server folders to the MS SQL user. And then what I'm doing in my Docker file is using setcap, which is a functionality available in this package. I'm going ahead and ensuring that SQL Server has permissions to connect to all the ports which are less than 1024. And these commands are then going ahead and ensuring that SQL Server as a non-root process can still take a dump. Because remember, all your SQL Server functionalities like the dumps, the error logs, the agent logs, all of that is something that's also available on SQL containers. And then because I've used setcap, it basically goes ahead and breaks certain dynamic links. So I'm just going ahead and setting those up again. And here I'm exposing 1433 as a port and starting my SQL Server from the binaries under the user MSSQL. So this is what I have in my Docker file. And going back to this, I can just show you the same to you in the Docker file that I have. And now if I want to go ahead and create an image out of this, all I've got to do is run docker build command, as you can see, and I'll call my image as /SUSE SQL tools 1. And when I hit enter, this is going to go ahead and build the SQL Server image. And I can see this image from Docker image and sorry, Docker images is the command. So you can see I have the image created. And what I can do here is, again, I can quickly go ahead and run a Docker command, which uses this image, which I've just created. I think I already have a container with the same SQL one already. So I need to first delete that. So I'll say docker rm SQL1 minus f. This should remove it and then run the same command again. This should work as it is. And now if I go ahead and take a look, the container has started. Let's just go ahead and look at the logs SQL1. And let's say I want to take a look at the first 35 lines of the logs. So it's still starting up. So that's why it's just taking a couple of minutes. So if I have to just connect to this, let's see if I can connect. So I'll just go ahead and run this command over here, give the password, which is not supposed to be typed in. I think I just made a mistake there. Let me just give the password again. So here you go. I'm connected. Let me do select add version. Go. Remember, when I started my container, I've used -hs equal 1. So what I expect an output here is for the version, I expect SUSE server 12 SP5, which matches with the base OS image that I have downloaded. And I've gone ahead and downloaded the latest SQL Server, which is CU8. And when I do a select at server name, you'll actually see the name which I've provided when starting my container. So this way, I have created my own container from the scratch using a base OS image and was able to create it. Now, you can add to this Docker file components like machine learning, DTC, and start working with it. So the idea here is that your SQL Server containers, while it is easy to deploy, while it is easy to use, they are completely secure, they are completely configurable, and something that you can control and start working in your production environments from day one. So with this, I think let's go ahead and go back to our slide. Now, what I want to really talk about is the main feature when you want to run something in production. What are your performance knobs? What are your tricks that you can use to actually tune SQL Server containers? Now, we have a very good document which is out there. The link is shared on the slide, which you can follow when you are setting up SQL Server on Linux. Now, because the SQL Server Linux containers runs on a SQL Server Linux host, the same document can actually be used for the host which are running SQL Server containers. And that document has configuration optimization options for both for OS level settings, for CPU level settings, for storage level settings. So my request is, if you are mounting volumes for SQL Server containers which are belonging to that host, follow the storage level settings which are provided provided there in that particular document for SQL Server on Linux host. But those same settings are also valid for SQL Server containers. We also have a tuned profile, which is specifically made, custom made for SQL Server, that you can use with these parameter values that you can configure your SQL Server Linux host to run with to ensure that out of the box, you get the best performance from SQL Server. With that said, I'm not going to go into details about each of these options because it's all very well documented in the link that you see on the slide. What I want to now quickly turn our focus to is the deployment options that you have for SQL Server Container when you want to deploy them on container orchestration environments. Now, you might ask, or you might probably be aware that container orchestration environments like Kubernetes, they provide you high availability already built in to the architecture itself. So if something happens to your SQL Server container, which is running on a Kubernetes cluster, by default or by automatically, it will be able to go ahead and run the pod so that if it goes down, it can immediately come up as well. So that's the benefit of running SQL Server containers on a container orchestration environment. Now, look at the slide here with some animations. I just want to show how easy it is. So in SQL Server container orchestration systems, you configure something called as a persistent volume, which is shared across the node. And you have a pod, which in this case only has one container, which is running as a SQL Server replica. And if you see, if something happens to this SQL Server replica, and if that node is still running, it will go ahead and create the SQL Server container on that same node. But if the node goes down, it also has the ability to actually go ahead and create the same SQL Server on another node. Now, the good thing about all of this is while the SQL Server node goes down and it comes up on the other node, all of this is taken care by default within the Kubernetes environment itself. At the same point of time, all your data that you've been working with is also saved because it's actually on the persistent volume, which is shared by all the nodes. So at the end of the day, SQL Server container again picks up and starts reading from that same persistent volume. Now, I think with this, what I want to show now is to take you to the demo where how you can configure SQL Server containers on Azure, Red Hat, OpenShift. Now, I'm showing this for Azure, Red Hat, OpenShift, but the same deployment YAML files can be used even on Azure Kubernetes Service. And again, on the slide, you will see a link which actually points you to that. So it's time for us to go and take a look at my Azure Red Hat OpenShift cluster. I have an OpenShift cluster which is created. Again, this is an Azure Red Hat OpenShift cluster which is created. And what I'm going to do is I'm going to run SQL Server on top of this OpenShift cluster. And to do this, the first thing that I need is I need a way to connect to my OpenShift clusters. And as you can see here, these are the commands that I have. I first get my credentials and then put in my credentials here to be able to connect to my SQL Server. Sorry, not SQL Server, but OpenShift clusters. So if I go ahead and run a simple command get all, it should get me all the resources that are currently running on my cluster. As you can see on my OpenShift cluster, I have no deployments yet. So what I'm going to show you is I'm going to show you the deployment YAML file that I've created, which I'm going to use on this cluster. So this is the deployment YAML file over here. As you can see, I'm going to go ahead and create a storage class first, then create a persistent volume claim based on that storage class. And then I'm going to deploy SQL Server with one replica set. The instance name or the host name that I'm going to have for my SQL Server is MSSQL deploy. And there are several, and these are the container specific options. For example, I'm getting my SA password from a secret that I've already created on my OpenShift cluster using create secret option command. And then I'm going to run a web edition of SQL Server, which is going to enable the agent, and I'm going to go ahead and get this SA password from the secret that is created. And my SQL Server container is going to run this build on Ubuntu OS. So all of these options, and then I'm going to create a service so that I can connect to my SQL Server, which is running on OpenShift from outside the cluster. So to do this, all I've got to do here is run the command, which is oc.exe apply -f. I think I have this command ready here, so let me just get it. So this is my deployment file. I just go ahead, hit enter. This is going to go ahead, create, it has gone ahead and created the storage cluster first. So if I just say get SC, you should see the storage cluster which just got created about 8 seconds ago. Then I also created a PVC. So I can just say get PVC, which is the claim, and you can see the MS SQL data getting created here. And now let's see what all resources got created. So I'll just go ahead and do get all. As you can see now, it has started creating my service. The service is already created, which is running here. The container is currently in container creating status. So if I want to go ahead and look at the description of this, all I've got to do is run this command here. So I'll just copy the name of my container and I will replace it over here. So this is the name of the pod, and you should see the container is started. So let me just clear this, go back up top here, and just run get all again. So this is an OC cluster, OpenShift cluster. And what I'm going to do is now I'm going to connect to this from outside of the cluster. So I'm just copying this, as you can see. So I'll go ahead and connect to this using my SSMS, which is running on my machine, or this is running outside the cluster. Provide the SA password in. There you go. I am now connected to SQL Server. My agent is up and running, and this is a SQL Server which is running on OpenShift, which is running Ubuntu. So if I can just go ahead and do select at version, and we execute this command, you'll actually see this is running a web edition as per my deployment file running on Ubuntu. And all of this is, SQL Server is currently an OpenShift cluster. And now if I just go ahead and also do a server name, there you can see this is the server name that I used in my deployment file over here as well. So all of this is from this deployment file. I was able to get it up and running. Now, let's say that my pod goes down or something happens, something bad happens to my pod. So let's say someone goes ahead and something bad happens to the pod. So all I'm going to do is OC delete, give the pod name here. So this is going to go ahead and delete the pod, and you'll see that automatically after the deletion, it also goes ahead and starts on its own. So we'll just give it a few minutes. Oh, I have to mention delete pod. I forgot that. My bad. So the pod's deleted, and as you can see, I just do a get all again. You should see a new pod already up and running. There you go. So this is a new pod which is already up and running. Let's see if my connection is still working. So let me just go ahead and say, or let me just run this command again. There you go. My connection is up and running. So my pod got deleted. SQL Server was deleted, but because it was running on a container orchestration system, it was able to get it up and running on its own. So the idea is you can go ahead and deploy your SQL Server in a container orchestration system, which has the HA abilities already inbuilt into it, and start using it from the day. Brings us to the end of our session, and I am so happy to be here, as I said earlier, and I'm now open for any questions or any comments that you might have. And I'm looking forward to answer your questions. In case you want to reach out to me, I'm also available on Amwin87, which is my LinkedIn ID. So you can just drop me a chat message, or you want to send me an email. I'm more than happy to take an email on amitkh@microsoft.com if you have any questions about SQL Server containers. Thank you so much for being with me so far, and looking forward to talk to you when things are back normal. And thank you once again. Have a good day.